NVIDIA's quantum AI fusion, the hybrid leap already underway. Intro for years, quantum computing has hovered on the horizon, a tantalizing promise locked away in fragile qubits, costly experiments, and theories that rarely left the lab bench. But 2025 may be the year the story shifts, and the shift isn't coming from who you think. While tech giants like IBM, Google, and Microsoft focus on pushing raw hardware limits, NVIDIA has taken a different route. Known for revolutionizing AI with GPUs and powering models like ChatGPT, they're now engineering something far more ambitious, a hybrid computing world where AI, quantum processors, and classical systems all work in sync. The twist? NVIDIA isn't racing to build the perfect quantum chip. Instead, they're using artificial intelligence to counter quantum's biggest weakness, instability, making practical quantum computing a possibility sooner than anyone expected. In this breakdown, we'll explore how NVIDIA is blending AI with quantum tech, how their plan stacks up against rivals, and why this approach could allow them to skip ahead in the race, because this time, the future of quantum might not begin in a physics lab. It could begin on a GPU board. The quantum roadblock. Quantum computing promises game-changing advances in fields like biotech, finance, cybersecurity, and AI itself. But there's a fundamental issue. Qubits, the quantum equivalent of bits, are notoriously delicate and almost impossibly difficult to stabilize. Heat, vibration, electromagnetic noise, even stray cosmic particles can flip them into error states. This fragility leads to corrupted calculations and severely limits the scale of working quantum systems. In practice, these errors can erase hours of processing in a fraction of a second. Traditional fixes mean adding more qubits for error correction and layering complex processes on top, which slows everything down and makes the machines even more expensive. For decades, that's been the bottleneck. The reason quantum has mostly stayed locked in research labs, talked about as the future, but rarely delivering results in the present. NVIDIA's alternative play. NVIDIA isn't a quantum hardware maker, but they are masters of AI acceleration and high-throughput computing. Instead of trying to eliminate every physical error, their plan is to use AI to watch for and fix those errors as they happen in real time without halting the process. Earlier this year, they opened the NVIDIA Accelerated Quantum Research Center, NVAQC, a hub that merges quantum processors, classical supercomputers, and AI-driven control systems into a single hybrid machine capable of balancing speed and stability. Neural networks run alongside quantum systems, detecting patterns of instability, predicting where errors will appear, and correcting them before they spread. The result? You can get useful output from imperfect hardware right now without waiting for flawless qubits. This fundamentally changes the timeline for quantum adoption, bringing it from someday to today. DGX Quantum and CUDAQ, the core tools. Two main platforms form the backbone of NVIDIA's vision. DGX Quantum, a hybrid hardware environment linking NVIDIA GPUs directly with quantum processors, allowing smooth data transfer between classical and quantum layers for faster, combined calculations that leverage the strengths of each side. QuDAQ, a quantum AI software framework that trains models to identify, simulate, and suppress qubit errors as operations run in real time, essentially acting as a digital immune system for quantum computers. Together, these create a complete stack, hardware plus error-handling software, already being used by developers to model complex systems today. This isn't a lab curiosity, it's operational tech in use, demonstrating that NVIDIA's approach works not just in theory, but in demanding real-world simulations across multiple industries. Building a quantum network. NVIDIA's not going at it alone. They've aligned with leading quantum innovators, Quantinuum, specializing in ultra-precise quantum hardware with industry-leading fidelity. QuEra pioneers in neutral atom qubits, enabling better scaling and control over computation. Quantum Machines, experts in orchestration hardware for synchronizing quantum operations down to the nanosecond. Partnerships with Harvard and MIT ensure a pipeline between academic discoveries and industrial-scale deployment. This isn't just about technology. It's about creating a global ecosystem where breakthroughs in the lab instantly feed into scalable, AI-driven quantum platforms ready for commercial use. Why it might work quantum has has been full of hype cycles. But NVIDIA's approach is different because it skips the perfect hardware waiting game. Their AI doesn't require flawless qubits, just enough data to predict and control them with unmatched precision. And NVIDIA already sits at the heart of modern AI and scientific computing. Their GPUs train the largest neural nets, run global-scale simulations, and power research in almost every technical field. Redirecting that capability towards stabilizing quantum systems could accelerate progress without the physics breakthrough others are still chasing. It's a pragmatic approach. Get quantum results from today's hardware and make them better over time with smarter AI models. By removing the wait for perfection barrier, NVIDIA could unlock commercial quantum applications years before competitors relying solely on hardware improvements. Potential industry impact healthcare and biotech. Quantum simulations of molecules could shrink drug development timelines dramatically, enabling precise treatments for diseases currently deemed untreatable and unlocking new pathways for personalized medicine. Finance. Analyze massive market data sets in real time. Optimizing portfolios and managing systemic risk with quantum-enhanced models capable of running billions of calculations simultaneously. Cybersecurity. Develop and test encryption methods resistant to future quantum attacks, ensuring data security before the threat becomes widespread. Climate science. Model environmental systems and weather patterns with unprecedented precision for disaster prediction, urban planning, and sustainable engineering. AI research. Hybrid quantum AI compute could power next-gen models faster and with far less energy than current supercomputers, opening doors to AI capabilities we can't yet imagine. These aren't hypothetical wish lists. Researchers are already experimenting with NVIDIA's hybrid tools in these areas, showing early but promising results. Rivals in NVIDIA's Advantage IBM focuses on commercial quantum cloud services, bringing quantum to customers via remote access. Google is scaling qubit counts and pushing quantum supremacy demonstrations to prove capability. Microsoft is betting on the yet unrealized topological qubit, a high-risk but high-reward approach. NVIDIA's Advantage already own the AI hardware space and are positioning themselves as the operating system for hybrid quantum AI computing. This gives them both the infrastructure and the market reach to dominate once the technology reaches wider adoption without needing to reinvent the wheel from scratch. The 2025 pivot. This year marks the operational rollout of NVIDIA's Accelerated Quantum Research Center. Full-scale simulations, real-time AI-driven error control, and expanded collaborations are all on the schedule, making 2025 a pivotal moment for hybrid computing. External developers and institutions will gain access to these hybrid systems, creating a global sandbox for practical quantum AI development. Think of it like the early cloud era, except this cloud combines quantum computing's potential with AI's adaptability and classical computing's reliability, potentially redefining what's possible in computing altogether. The big picture quantum progress has always been a tug-of-war between scientific idealism and technical pragmatism. NVIDIA is betting that smart software can get us over the finish line faster than perfect hardware ever will. It's less about building the world's biggest quantum processor and more about making quantum genuinely useful in the real world. If they succeed, NVIDIA could move from AI giant to the leader of the hybrid computing age, leapfrogging rivals entirely and reshaping the future of computing itself. Outro: for decades, quantum computing has been 5 years away. NVIDIA is trying to change that by merging AI intelligence, classical speed, and quantum potential into one system. The challenges are massive, but so are the rewards. The real question now, will this hybrid strategy finally push quantum computing into everyday use, or will it stall like so many attempts before? Drop your thoughts in the comments. And if you want more deep dives into AI, quantum breakthroughs, and emerging tech, subscribe and stay tuned, because the next time you run an algorithm may not run on just silicon, it might run on something quantum and something smarter.